For many students, high school chemistry begins and ends with staring at a lifeless molecular diagram on a page. This is often how colloidal systems are introduced, defined abstractly as the science of how mixtures, emulsions, and suspensions behave at a microscopic level. Standard Western curricula typically prioritize the memorization of these definitions. You learn the terminology to pass a test, but the concepts rarely connect to anything you can see or touch. This creates a disconnect where science feels like a theoretical, imported subject, something that happens in a book but not in a student's actual life. Educators at SMA Seminari Santu Rafael Kupang in Indonesia decided to address this gap by looking at their own surroundings. In 2024, researchers Tangi and Tinenti proposed a different path, teaching chemistry through the lens of local culinary heritage. They replaced the textbook with the raw ingredients for Waelia, a traditional Indonesian drink made from local spices, rock sugar, and specific botanical extracts. This ethno-STEM approach transforms indigenous heritage into the laboratory equipment needed to observe and unlock complex scientific principles. The classroom becomes a workspace where students physically mix these raw, colorful ingredients into a large pot of water. They start by observing a suspension, watching how solid spice particles interact with the liquid before any energy is added to the system. As the mixture boils, students track phase changes in real time. Added heat causes molecules to break bonds, transitioning solids into liquids and gases. Through this process, the extracts combine to form an emulsion, a stable mixture that stays integrated rather than separating. Each step in the traditional Waelia recipe serves as a precise laboratory protocol for manipulating these complex colloidal systems. While the students use modern scientific vocabulary, the creators of this drink relied on generations of direct observation and trial. Perfecting Waelia required mastering the exact temperatures needed to extract flavors and the specific ratios required to keep the botanical compounds stable in the water. This culinary heritage reflects a sophisticated grasp of chemistry and thermal properties, highlighting the intellectual rigor preserved within traditional culture. To validate this method, the researchers measured actual chemical competency, looking for genuine mastery of the concepts rather than simple student engagement. The data showed a massive spike in performance. Student skills and material mastery reached 98.1% when rooted in their culture. Even more significant was the secondary metric, a 94.09% rate of deep comprehension for complex colloidal systems. This data identifies ethno-STEM as a highly effective pedagogical vehicle for teaching the hard sciences. This shift in teaching achieves a dual victory. It vastly improves scientific literacy while actively preserving localized cultural heritage. We often associate real science with multi-million-dollar facilities, yet the same complex chemical reactions are happening every day in a traditional kitchen. Ultimately, the most sophisticated chemistry isn't just found in a textbook. It is already bubbling in our heritage, waiting to be understood.